So my dear children, now I have with me several volumetric flasks. So this is a volumetric flask of 250 milliliters. Here this is 100 milliliters, and now within here a 500 milliliter beaker, right? So this is the instrument which is referred as the triple beam balance. So we use this triple beam balance to measure the masses of substances. So there are three loads of weights here, here and here. So by moving these weights here and there, we can measure the masses of certain substances. Now till the mass is going to be tallied with the mass that we are going to apply, right? So we have to move these bars here and there. So how to find out whether the mass is getting tallied or not? So you check the bar which is over here. So there is a line over here, there is a line. So that line should tally up with the line which is over here at the bar. So if it is getting tallied, then the mass is equal to the amount which is in here. So as there are three bars, so in the first bar you can observe, now here it is being printed, this is mentioned from grams, 10, 20, 30, 40, and here once again here it is being mentioned from 100, 200, 300, and here 1, 2, 3, 4, 5 up to 10, right? So what you have to do, you have to move these things here and there, and you have to get the exact value of the mass of the substance. So this is how to use the triple beam balance. You will get to know how to use this thing when I'm doing the experiment, right? Now our experiment is very simple. What you have to do is, you have to take three different volumes of water, and within these volumes of water you have to measure the masses, and after that we are going to find out mass over volume ratio. Okay, mass over volume ratio. Right, now first of all, my dear children, I'm going to place the beaker over here. So now observe, now the two lines are getting tallied each other. That means there is no mass, mass is 0. So now I'm going to place this thing over here. Now you can see the two lines are not getting tallied. So until it's going to tally, I'm going to move these weights here and there. By that way, I'm going to measure the masses. So there are arrowheads over here, right? Like this, you can move these. Right? So let's keep it in here. Let's take the heavier mass down. Okay. Now gently let's take the others. Now we'll try it from here. Right, so my dear children, I have moved the weights. Now, as you can see here, the larger weight, which is measured from 100 grams each, it is at the 100 level. You can see it very clearly over here. It is at the 100 level. The second one, which is measured from 10 by 10 each, is at the 30. And the smallest one, which is measured from 1 gram each, it is at the 9.5. Right, as you can see here, it is at the 9.5 level, 9.5. So 100, 30 and 9.5 altogether, the entire mass is 139.5. So as you can see here, now the two indicators are getting tallied each other. That means the mass of this beaker is equal to 139.5 grams. 139.5 grams. Okay, 139 grams is the value of the beaker, right? Value of the beaker. Now once again, I am taking these weights to here. So let's see whether it is getting tallied until, so before you are measuring any kind of a mass, remember to take the indicator exactly to the middle. I mean, like these lines should tally each other. The two lines should tally each other. Right. So as you can see here, before measuring the other masses, you should know, I mean, like you have to take these two readings to the same level. Okay. Right. Now, you know that the mass of this beaker is equal to 139.5 grams. Okay, 139.5 grams. Now let's keep it over here. Right. Now what I'm going to do is I'm going to take this 100 milliliter volumetric flask. 100 milliliter volumetric flask. So now what I'm going to do is I'm going to measure exactly 100 milliliters of water by using the volumetric flask. Right, now within this one, as you can see, there is 100 milliliters of water. Right, there is 100 milliliters of water. Right, now actually here now 1 milliliter is missing. You can see here very clearly it's 1 milliliter, like 1 milliliter is less. If I'm going to pour it by using this beaker, then the level might rise up. So in that case, I'm going to use a special tool. This thing. This is the dropper. Right? So the dropper can be used. So let's add . Right. Now observe once again. Right. I think now the level is at 100. Right. Now as you can see here, now the level is exactly at 100. Okay. So now what I'm going to do is I'm going to take this water and let's insert this water to the beaker. Make sure you pour all water into the beaker. One single drop. Till the last drop you have to pour everything to the beaker. Otherwise your masses will get different. Okay. So remember to put each and every drop to the beaker. Right. Now let's keep it over here. And now I'm going to measure the mass once again. So we have to move it. Right. Okay, so let's move on with the next one then, the smaller one. Right, so this is 100 milliliters of water which is in the beaker. Earlier the empty beaker was 139.5. Now you can see that here the level is tallied. So let's count. Right, so here 30, 200 and 8.6. So entire answer would be 238.6. 238.6. 238.6 is the mass of 100 milliliter of water with the beaker. Okay, 238.6. Right, so I'm going to remove this thing now. Let's take the masses once again to the initial position. And now I'm about to measure 250 milliliters of water. 250. Right, once again I'm going to use the dropper. Let's keep the beak over here. Right. So 250 milliliters of water, my dear children. Once again, I'm going to pour 250 milliliters of water into the beaker. Pour each and every milliliter of water, each and every drop of water to the system. You have to remember it. Otherwise, you will get faulty readings. Right. Now, once again, let's check the mass of this thing now. So here, the heavier mass is at 300. Second mass, as you can see here 70, now it is at 80. So here 300 and here 6.6. So altogether 386.6. 386.6. Right, 386.6 is the answer for 250 milliliters of water. Okay, 250 milliliters of water. Right. Now the final step. Now you know that in this beaker there is 250 milliliters of water. What I'm going to do is I'm going to measure another 250 milliliters of water by using the same volumetric flask, and I'm going to insert it. So altogether it would become 500 milliliters. So let's insert another 250. So like in the previous instances, I'm going to use the dropper. Right, here we go then. another 250 milliliters of water, right? Another 250 milliliters of water. Already there is 250 over here, right? Now I'm going to pour this 250 into the system once again. Right, make sure you drop each and every. Right, now once again we'll balance the system to get the answer. So I'm going to move this thing. So this is the maximum that I can reach, my dear children. With the triple beam balance, this is the maximum which I can reach. So as you can see here, even though I have moved the heavier mass to the 500, I won't be able to get a reading over here. So in that case, there's a special weight. So it is over here. This is the special one. So you have to hang it over here like this, right? So when measuring masses more than 500 grams, we need to hang this weight within this needle head over here. Okay, there is a pin head over here, so you have to hang that thing like this. Now you can measure the masses which is greater than 500. So when you are measuring masses, make sure when moving this thing 100 units, like in here 500 plus this one, altogether 600. 600, 700. See, so it's not that much, it's not having that much of a mass, so we'll keep it in 600. 500 plus 100, 600. Now let's move this thing. Okay. Right, so here let's find out the mass. Now I have a balance. Now I have balanced it, my dear children. There's a 500 extra mass over here. So here there is 100. So 500 plus 100, 600. Then over here 630, 633.8. 633.8. So here 500, 600, 630, 633. So 633.8. So 633.8 is our answer for the mass of 500 milliliters of water. 638.8. Okay, 638.8 is the final answer for the 500 milliliters of water. The mass of 500 milliliters of water is 638.8. Right, so we have took the readings, my dear children. Right, we have took the readings. Now let's head on to the classroom once again and we'll write down these observations one by each, and by looking at the observations, let's come into a conclusion onto how to find out the ratio between mass over volume. Okay, so let's divide these masses by the volume and we'll find out a nearest value. Okay, let's see whether whether this ratio is going to change or not when you measure the mass upon when you measure the, or when you take the mass upon volume ratio. Okay, so now let's head on to the classroom once more and we'll check out whether the ratio is getting changed or constant in this water. Right, my dear children, now within this activity I'm going to measure several masses of several liquids. Actually, I'm going to take 250 milliliters of different kinds of solutions. So especially we are using 3 kinds of solutions over here, liquids. These 3 liquids are pure water, then secondly salt solution, and 250 milliliters of coconut oil. So we're going to measure first of all the mass of this empty beaker. As you can see here, 250 can be observed. So I'll place this thing. Before that, check the reading, my dear children, whether it is getting tallied or not. Yes, exactly, the 2 lines are getting tallied each other. So let's keep the beaker over here. Right, so before now my dear children, before you are going to enter water in or any kind of a solution into the system, first of all you have to measure the mass of this beaker, right? So now I have kept the beaker over here, so let's measure the mass first. Let's take this thing to the 100 first. It's less than 100 then. So we'll keep this thing over here and we'll take the 10 gram weight towards right. Okay. Now the smaller one. Right, so I have measured the mass of the empty beaker, my dear children. 10 gram one is at 70, 100 gram one is at 0. Here, this one is at 2.5. So altogether 72.5. This is the empty beaker. Mass of the empty beaker is 72.5 grams. 72.5 grams is the mass of the empty beaker. Now what I'm going to do is I'm going to take this volumetric flask of 250 milliliters. Okay. And I'm going to pour water into this and I'm going to measure 250 milliliters of water. So like in the previous, when I measure in smaller quantities, I'm going to use the dropper. Always keep the volumetric flask at your eye level. Right then, 250 milliliters of water. Right, 250 milliliters of water, my dear children. Now, as you can see here, this is the mass of empty beaker. Now, I'm going to insert this 250 milliliters of water into the beaker. And let's check the mass. Right. So here we go then. Now we are going to measure the mass of this beaker which contains water. Right, water is filled up to 250 milliliters. Right, so let's check how much is the mass of this 250 milliliters of water. Right, so here we go then. The two lines are getting tallied each other. The heavier mass is at 300. Next one 10 by 1 is at 10. And here this one is at 9.6. So 319.6 is the answer. 319.6. Okay, 319.6 is the mass of 250 milliliters of water with the beaker itself. Okay, right. So let's take this thing once again. Pour down this tin to the container once more. Now I'm going to measure. Let's keep it over here. Now I'm going to measure 250 milliliters of salt solution. Okay, so let's take a salt solution and we'll measure it. Right, my dear children, this is the second solution, common salt solution. So let's take 250 milliliters of common salt now. 250 common salt. Okay, let's see. I can add like few drops. Right. Now let's take the dropper once more, and we'll use the dropper to put the extra ones. Right. Okay, my dear children, here we go. 250 milliliters of sodium chloride solution, common salt. Okay, 250 milliliters of common salt solution. Right, so let's add this thing to the beaker once more, and we'll measure how much is the mass. Right, now let's measure the mass, my dear children. So right, so the larger mass, heavier one is at 300. The second mass is at 320, and over here it's 9.2, right? Here it is at 9.2. So 329.2. 320. So here 320 and 9.2. 329.2 is the answer for the 250 milliliters of common salt solution with the beaker, my dear children. Okay, the mass of 250 milliliters of common salt with the beaker. 329.5. 329.2. 329.2. Right. Okay, now let's head on to measure the mass of coconut oil, 250 milliliters. Okay, but remember, when you are inserting coconut oil into this beaker, make sure this thing is pretty much dry, right? Otherwise your values will get faulty. Okay, so you pour this thing down, and you have to clean it. You have to clean the beaker very well before entering coconut oil into the system. Okay, right then. So we'll measure 250 milliliters of coconut oil in our third step. Right, then I have with me coconut oil, my dear children. So as you can see here, now the beaker is also dry and the volumetric flask is also dry. Okay, so remember to dry these things out before you are going to measure the volume of 250. Okay, now let's add and get the 250. Right. So coconut oil layer is somewhat hard to find. So you have to keep your eyes somewhat closer to the level, right, of the 250. And also with the air bubbles coming out from the coconut oil solution, my dear children, it's somewhat difficult to measure 250. But however, now I don't think that you could observe the 250 level very clearly, but however I know that I have measured it very clearly. So you have to keep it somewhat closer rather than the water, right? You won't be able to see it very clearly, but for the naked eye it's very clearly visible. Okay, so this is 250 milliliters of coconut oil. Now I'm going to pour this thing into the beaker once more, and let's observe the mass. As the coconut oil is having some amount of a viscosity, I mean, like if you take the viscosity, so it's somewhat denser. That's why it is having a heavier viscosity. Actually denser in the sense somewhat thick. Okay, density is not that much high, but however it is somewhat thick, my dear children. The viscosity is somewhat high. It is referred as the viscosity. Okay, right. So try to add each and every drop into the system. Right then, so here we go. Then now let's measure the mass of it. Right, so this is the third solution, my dear children. Third and the final solution, coconut oil, 250 milliliters of coconut oil. Let's see how much is the mass of it. Here this is at 200, here this is at 90, here 8.2. So altogether 280, 290, 80 here 90, 298.2, 298.2, right? 298.2 is the mass of coconut oil with the beaker, right? 250 milliliters of coconut oil with the beaker, mass is 298.2, right? So these are the masses of different solutions, my dear children. We measured the mass of 250 milliliters of water and 250 milliliters of coconut oil and also 250 milliliters of common salt solution. Now let's head on to the classroom and we'll tabulate our readings. So my dear children, now within this activity, we are going to test the density of each, there are several solutions. So we are going to check the density of each and every solution. We are going to take 3 solutions, and from those 3 solutions, we are going to take the density reading separately by using the hydrometer that I have over here. So this is the one which is referred as the hydrometer, my dear children, the hydrometer. So as you can see here, the hydrometer, so within this hydrometer, the largest value is over here, 2.0. And from that, you can see the values of the hydrometer is keep getting decreased up to 0.7 over here. That's the least value. So when the hydrometer is dipped in any kind of a solution, if more amount is getting down, right, if more amount is getting sink within the solution, then the density is less. If more amount is floating on the solution, then the density of that solution is high. So I have with me right now, this is a solution, this is actually water which I have taken from the tap. Okay, so this is normal tap water. So at the end of the hydrometer, as you can see here, right, at the end of the hydrometer, there is some lead shots. These are lead shots, smaller lead shots. So this will allow to sink hydrometer up to a certain level and to float on the solution, right, or the liquid that we are going to insert. So by that way, we will be able to measure the density of that particular solution or the liquid. So now it's time to insert this thing into the water that we have, and let's observe how much is the density of water. Gently we will insert this thing. Right. So I'm going to turn this thing so that you guys can observe it. So as you can see, the density of the solution which I have here over now is nearly 1000. This is, I told you that this is water. So the density of water is 1000. This is given from using the unit kilograms per cubic meter. Kilograms per cubic meter. So as you can see here, it's equal to 1000, right? 1000 kilograms per cubic meter, right? So the density of this water contained within the, so density of water contained within the vessel over here is equal to 1000 kgm minus 3 kilograms per cubic meter, right? 1000. So now my dear children, let's insert kerosene oil as the second solution into the vessel over here, and we'll measure the density of the kerosene oil, and let's check whether the value of, whether the density of the kerosene oil that we are going to receive from the measurement is going to tally with the table which is given in your textbook. Okay, so let's go ahead with the kerosene oil and we'll measure the density of kerosene oil now. Right, my dear children, so now I'm going to insert the hydrometer into the kerosene oil over here. Remember, before inserting this thing into the kerosene oil or to any other solution, you need to wipe out this hydrometer very well, because earlier we measured the density of water, no? So we have to remove that water, otherwise your readings will get faulty. So by using a tissue paper, make sure to remove and to wipe out all the liquid which measured earlier. Okay, all right, now once again I'm going to insert this thing into the kerosene oil solution. Right, so gently I have inserted it into the kerosene oil. So I'll take the reading first, then I can show it to you. So my dear children, now as you can see here, first of all I'm going to take out a reading, then I'm going to show it to you guys as well. So here from the top, remember that the measurement should be taken from the top to bottom. Okay, so the top here it is 700, 7.5 is there, nearly it is about 7.6, we can say it as 7.6. so 7.6 means in here 760. Okay, as you can see here there is 760. so now I'm going to turn this thing towards you guys. Check it very clearly. It is under 7.6, somewhat under 7.6, but we'll round it off and take it as 7.6. so that means 760. So the density of kerosene oil is nearly 760 kilograms per cubic meter. Okay, 760 kilograms per cubic meter. So as you can see here, the value can be clearly observed. Here it is 700 and here 7.5, somewhat greater than 7.5. So 760. Rounded off value is 760. So 760 kilograms per cubic meter is the density of kerosene oil, my dear children. So let's now head on to the third and the final liquid that we have, that is coconut oil, my dear children. So we'll clean this thing out. So I'm going to take the hydrometer out and we'll clean it, and let's go ahead to measure the density of coconut oil. Okay, so my dear children, this is the third and the final liquid that we have. So this is coconut oil. So once again I'm going to wipe out the kerosene oil which is on the hydrometer that we have. So let's wipe it very well. Right, then let's insert this thing into the coconut oil and we'll check how much is the density. Nearly 900. Yes, 900. So I'll turn this thing towards your side. Observe it clearly. Here 700. Then here at this level you can observe 900 or 0.9. So 900 is the answer or the value that we have obtained for the density of coconut oil. So this is equal to 900 kg m-3 or kilograms per cubic meter. Okay, for each and every cubic meter the mass of coconut oil is equal to 900 kilograms. Okay, 900 kilograms per each and every cubic meter. So that what's the density means, right? So we took the answer separately for the coconut oil, kerosene oil and for the normal water, right? So let's head on to the classroom, my dear children, and we'll tabulate our readings then. So my dear children, within this activity, we'll be making a prototype of a hydrometer. So this is the hydrometer that I have used earlier to measure the densities of different liquids. So you know that we measured the density of kerosene oil, coconut oil and water by using the hydrometer. Like I said in the earlier, the bottom corner of the hydrometer is firmly filled with lead shots, and by putting out some amount of wax, it's been sealed. As you can see, those things are not coming out. So when you dip this thing in a solution, it will float and the reading will allow you to take the necessary amount. Okay, so amount means the necessary reading of the density. So now we are going to make a prototype hydrometer which is going to be same as this thing. So in making this prototype hydrometer, I have with me a straw, a plastic straw and several bicycle balls. Okay, so what I'm going to do is, so I'll keep this thing away safely. Right, so what I'm going to do here is, I'm going to insert these bicycle balls into our tube like this. Okay, you need to insert the bicycle balls into our tube or to the straw like this, and insert that straw onto the liquid and observe whether it is getting sink like up to two-thirds of the size or the level of the tube over here. At least it should sink up to two-thirds of the level. So by that way it will freely flow within the water. Now as you can see here, by inserting one, it will not float like in the previous case. So as you can see, it's now been bent to a certain direction. So that means we need to increase the weight below it. So now let's insert another one like this. Okay, so let's insert another one like this and we'll check now what's going to happen. Now it's okay, right? So like that way you need to prepare a hydrometer, a simple hydrometer like this. So it should be held vertical like this, and like up to two-thirds of the level of the straw should be underneath the solution. So I'm going to take this thing out now. Okay, I have prepared a special kind of a prototype hydrometer with me. So I'm going to take that thing. So here, this is that prototype one. Here my dear children, now in the earlier case I have inserted only two, no? So now here there are three bicycle balls inserted into the straw, and straw being cut out from a certain height. So if you want, you can cut it out, but here we are going to compare the density values of water compared with the kerosene oil and other different kinds of solutions. Okay, so now let's insert and get a reading from normal water. Now you can see that two-thirds of the hydrometer or the straw is getting into the liquid. Two-thirds is now sunk within the liquid. So now what do you have to do, my dear children? We'll mark out the level, right? So we'll mark out the level. I'll insert the finger and I'm going to mark out the level of it. Okay, it's about this level. About this level. So I'm going to insert once more. Right. So the marker is somewhat below. So I have to recheck it. So I need to mark the level Exactly, I'm going to mark the level, my dear children, right? So I'm going to mark this level, okay, by using a marker pen. I'm going to mark it down. So this is the marker pen, I'm marking it out now. Right, now let's insert it once more and see whether our mark is correct or not. Right. Now as you can see here, our marker is now at the same level as the water. See? You can observe it very clearly. This is the hydrometer which I have prepared by using the straw. So it has the same level like this, see, as the water, right? Okay, now I'm going to take this out and let's dip it in a different solution like kerosene oil or coconut oil or any other different kind of a solution, okay? And let's observe what is the density of that particular liquid compared to the density of water over here, whether the density is high or whether the density is lower than this thing, okay? Right, so we'll use a different solution and we'll observe what is going to happen with the density compared to the water. So my dear children, this is the second solution. So this is salt solution, okay, common salt solution. So like we discussed, my dear children, you know that when dissolving certain things, especially solids in water, you know that the density is going to change somewhat. Especially when you are dissolving solid substance within water, the density of the water is going to increase. Density of the water is going to increase, my dear children. So in the earlier case, we prepared a special hydrometer and this was the level, right? This was the level of water, right? This was the level of water. Now within water, this hydrometer sank up to this much of a height. Okay. So now I'm going to insert it into this particular salt solution and we are going to observe what is the level or up to which level does the salt solution is going to sink this hydrometer. Okay, so if the salt solution is going to sink this hydrometer greater than the marked level, I mean like if more amount is going to sink within the liquid or within the salt solution, then we can say that compared to the water, compared to the density of water, salt solution is having a lesser density. Okay, it is having a lesser density. Why it is having a lesser density? Because more amount is getting sink within the liquid. If more amount is getting sink within the liquid, then the density is less. If more amount is floating on the liquid, then the density is high. Okay, so up to this level, right, up to this particular level, water, right, up to this particular level, water sink the, right, or water has sunk the hydrometer which I have prepared over here. Now let's insert into the sodium chloride or common salt solution and we'll observe like to which kind of a level, right, like up to what kind of a level does this sodium chloride solution is going to sink this hydrometer. So let's insert and observe. Right, as you can see, it's very clear to us that earlier it was up to this level, but however now the level has been reduced. Somewhat lesser amount is going to sink within the sodium chloride solution, my dear children. If less amount of hydrometer is going to sink within the sodium chloride solution, then we can say that the density of sodium chloride or density of common salt solution is greater than that of water. That's why there is a clear difference between the two levels. In water, like 1 centimeter of a height, like up to 1 centimeter, right? Yes, like up to half of a centimeter, not just one, half of a centimeter to a height, right? There is a difference between like half of a centimeter, right? So half centimeter is greater in normal water, the length which has sunk within the liquid. Okay, half centimeter, like half centimeter is more than, like half centimeter more than this level is going to sink within the normal water. But however, in sodium chloride, half centimeter is lesser than the initial. Okay, so by that way we can say that, okay, by that way we can say that, we can conclude that density of sodium chloride solution or common salt solution is greater than that of water, right? Right then, so let's see the density of another solution, okay, compared to the density of water. So we'll use another solution and we'll observe the density then. Right, so this is the third solution that we have, my dear children. Okay, so by the looks of it, you know that this is coconut oil. So I'm going to insert the hydrometer which I have prepared into the coconut oil, and let's see whether the level is going beyond this level or above. Okay, so if more amount is going to sink, then we can say that the density is less. If less amount is going to sink, then the density is high. Okay, so you know that coconut oil having a lesser density than water, so it should go beyond this level. So we'll see whether it is going or not. Yes, as you can see, it's very clear to us that it is going beyond the level, right? So in here you can observe the initial level, that was the level of water. Now it is very clear to us that the density of coconut oil is lesser than the density of water. That's why more amount is going to sink within the liquid. Okay, so this is the comparison of the densities of these liquids, right, compared with the water, my dear children. So we discussed the comparison of two different liquids. Okay, first we took coconut oil, first we took salt solution, then we took coconut oil. Salt solution had a greater density than the water, and coconut oil, as you can see, it is having a lesser density than water. More amount of hydrometer is going to sink within the coconut oil. However, less amount of hydrometer is going, or less length of hydrometer is going to sink within the salt solution, right? So our benchmark was the level at water. Okay, the length of, or the sink level at water was our benchmark. So compared to the benchmark or compared to the water level, right? So this is having a greater length. That means the density is low. The previous one was having a lesser length. That means the density was high. So now let's head on to the classroom and we'll observe what are the other things contained in the lesson part.